Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss about non-contiguous memory allocation in detail. So I request everyone to watch the complete video for better understanding. In the last few videos, I have discussed about the contiguous memory allocation. In contiguous memory allocation, we have two strategies. One is the fixed size partitioning and another one is the variable size partitioning. In fixed size partitioning, the main memory is divided into fixed number of partitions where the size of each partition may be same or different. In fixed size partitioning, we have the several problems. One is the internal fragmentation and another one is the external fragmentation. There is a restriction on the number of process, meaning is that restriction on the degree of multiprogramming and restriction on the size of a process also. So we have four limitations in the fixed size partitioning. One is the internal fragmentation and another one is the external fragmentation and the restriction on degree of multiprogramming. Why this restriction comes? Because we are dividing the main memory into fixed number of partitions, and in contiguous memory allocation, in one partition you can keep at max one process. So if you have four partitions, at max you can keep four processes. So there is a restriction on the degree of multiprogramming. Okay, and similarly there is a restriction on the size of partition. Suppose let's take that you have divided the main memory into four partitions and the size of each partition is 8 KB. If you have a process of 16 KB, can we allocate the 16 KB memory to the process P1? No, not possible. Why? In contiguous memory allocation, spanning is not allowed. So this concept we'll call it as external fragmentation. So there is a restriction on the size of the process. These three limitations, such as internal fragmentation, restriction on degree of multiprogramming and restriction on size of process, has been overcome in the variable size partition. In variable size partition, we will dynamically partition the main memory based on the requirement of a process. Is it clear? So we will not have internal fragmentation, degree of multiprogramming and restriction on the size of process in the variable size partitioning. However, we will have external fragmentation problem. Okay, this external fragmentation can be overcome using the technique called compaction. But the compaction is a complex process, so that's why we will say that in contiguous memory allocation, in variable size partitioning, we have a limitation called external fragmentation. Now in non-contiguous memory allocation, how this external fragmentation will be overcome, I will discuss in detail for you. Let me erase this one. So look at this one. We have a main memory of 16 KB. Okay, out of the main memory of 16 KB, some part is occupied by the operating system. Okay, and some partitions are already used. This partition is used and you have a free space of 2 KB, and again there is some partition is already used and you have a free space of 2 KB. Now there is a process of P1 which requires 4 KB of main memory. If it is contiguous memory allocation, can we allocate the memory for this process P1? It is not possible because in contiguous memory allocation, spanning is not allowed. So this concept in contiguous memory allocation, the problem we will face here is the external fragmentation. Now in non-contiguous memory allocation, what we can do is that as we have a 2 KB free space, here 2 KB free space is there, we will divide the process P1 into two parts. So part 1 we will keep here and part 2 we will keep here. So there is no problem, we can allocate the total 4 KB free space for this process P1. Is it clear? Are you able to understand? So the external fragmentation problem has been overcome. Now we will discuss one issue with this technique. Now let's take that you have a 2 KB free space, 2 KB free space is there. Let's take that again there is a some used space and again you have a 1 KB free space is there. Let's take that this time process P2 with a requirement of 5 KB came. Now you have a free space of totally 5 KB. If it is contiguous memory allocation, can we allocate? No, it is not possible. But in non-contiguous memory allocation, what I can do is that I can divide this process P2 into 3 parts. Part 1 consists of 2 KB, part 2 consists of 2 KB, and part 3 consists of 1 KB. So I will keep the part 1 in this hole, part 2 in this hole, and part 3 in this hole. Is it clear? But if you look at this problem is that based on the process size and based on the holes, we have to divide. Then you can say that, sir, this is similar to overlay. But in overlay, the programmer is doing the task like dividing into and loading all these things. There is no support from the operating system. But in non-contiguous memory allocation, the entire task will be done by the operating system. But according to the size of the holes or the number of holes, dividing the process during the runtime is very tedious task. Is it clear? Are you able to understand? So to overcome that one, we have a concept called paging. Now let me discuss the paging concept in detail for you. Okay, we have a main memory of 16 KB free space other than the operating system. Let's consider that. Okay, just for your understanding. Now the size of main memory is 16 KB here. The size of the main memory, we will call it as physical address space. Okay, are you able to understand? And similarly, we will have a process P1. The size of the process, we will call it as logical address space. Now remember one thing, always the physical address space in one computer, if you have a main memory which is a fixed, then the size of the physical address space is same, but the size of the logical address space will be different because a process always will not have the equal size. Am I right? Suppose let's take that this process having the 4 KB. Let's take that there is another process P2 which has the 5 KB. Are you able to understand? There is another process P3 which have only 3 KB. So the logical address space will always change, but the physical address space will be same. Okay, are you able to understand? Now let's take that. What will happen is that the main memory is logically divided into frames. The main memory, which is physical address space, will be divided into frames, and the process will be logically divided into pages. So a process is a collection of pages and main memory is a collection of frames. And remember one important point, always the size of a frame should be equal to size of a page. Why it is required? Why not the size of a frame can be greater than size of a page? Let me discuss with a simple example. Okay, let's consider that your frame size is 2 KB, okay, and page size is 1 KB. Now, what is meaning of the frame and the page? The part of the process has been kept in the main memory, because let's take that we have 4 pages. Okay, so page 1 will be kept in one of the frame, page 2 will be kept in one of the frame. Suppose this page is kept in this frame. Now a frame of 2 KB is there, and if you keep a page of 1 KB, then another 1 KB of free space will be wasted. We cannot keep another page in this frame. So this problem we will call it as internal fragmentation. To avoid the internal fragmentation and external fragmentation, always the size of a frame should be size of a page, so that the entire page exactly fit in one of the frame without wasting any space. Okay, now let me discuss about this non-contiguous memory allocation in detail for you. Let's take that we have a main memory of 16 KB and the size of a page size they have given as 1 KB. If page size is 1 KB, then obviously frame size is also 1 KB. Am I right or wrong? Now, if your main memory is 16 KB and the size of a frame is 1 KB, the number of frames in main memory is equal to size of main memory by size of frame. Now look at in this example. Size of main memory is how much? 16 KB and size of a frame is 1 KB. So you will have 16 pages. Are you able to understand? Now let me write them. 0 page, 0 frame, frame number 1, frame number 2, frame number 3, frame number 4, frame number 5, frame number 6, frame number 7, frame number 8, frame number 9, frame number 10, frame number 11, frame number 12, frame number 13, frame number 14 and frame number 15. So we have totally 16 frames in the main memory. Let's consider that process P1 is of 4 KB. If process P1 is 4 KB and size of a page is 1 KB, then how many number of pages will be there in P1? 4. Why? Number of pages is equal to size of a process by size of a page. Now size of this process is 4 KB and the size of a page is 1 KB. So 4 KB by 1 KB is 4. So number of pages you will have 4. Okay. So this is page number 0, page number 1, page number 2, page number 3. Similarly, let's take that this process has 5 KB. Then how many pages it will have? 5 pages. Page number 0, page number 1, page number 2, page number 3, page number 4. Is it clear? Are you able to understand it or not? Now let me erase this one. Now look at it. This process P1 need to be allocated in the main memory. Now it has 4 pages. So page 1 of the process P1, page 2, page 3, page 4 will be allocated in the first 4 frames. Then you can ask me, sir, you are talking about non-contiguous memory allocation, but you have allocated the entire process contiguously. If continuously free space is there, why can't you allocate? Is it clear? Are you able to understand? It is not always a rule that even if you have a continuous free space, you should allocate non-contiguously. That's not required. Is it clear? Similarly, let's take that process P2 has 5 pages. So we need 5 frames from the main memory. Okay, let's take that process P3 is of some, how much? I can have 8 KB. Let's take that. Okay, then how many pages it will have? 8 pages. Then we need 8 frames. So P3, 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 P3. How many? 3, 4. Okay, let's consider this is 7 KB only. Okay, this is 5 plus 4, 9. 9 plus 8 is 17 KB. It is not possible. So let's consider that this is only 7 KB. 7 pages are there. Then we can allocate like this. Let's consider that process P1 has completed its task. Okay, then whatever the memory has been allocated, it will be deallocated. Similarly, process P3 has completed its task. Then we have to deallocate this memory for the process P1 and P3. Let's consider that a process P4 of size 11 KB came and it requires 11 frames of the main memory because it will have 11 pages because the page size is 1 KB. So as it is having the 11 pages, we can give this frame for the process P4, P4, P4. These 4 frames we can give and these 4 frames we can give. Now if you look at it, is non-contiguous. Am I right or wrong? Is it clear? Are you able to understand? So this is about the non-contiguous memory allocation where we will divide the main memory into frames and process will be divided into pages and the size of a frame will be equal to size of the page. Now you can ask me, sir, CPU will ask a 6th byte from the process P1. It will never ask that 6th byte from the main memory. It will ask the 6th byte from a process P1 or from a process P2. So CPU will always generate the logical address. This logical address depends on the logical address space, meaning is that size of a process. Okay, now this space is divided in the or stored in one of the frame. Are you able to understand it or not? So you need to find the equivalent physical address. So there will be a memory management unit. It will convert the logical address into a physical address. This physical address will be divided on the physical address space. Are you able to understand it or not? So the physical address space is nothing but the main memory. Now let's consider that you have a process P1 of 4 KB and you have the main memory of 16 KB. Is it clear? And your page size and frame size is 1 KB. Then how many bits will be there in the logical address, how many bits will be there in the physical address, and how the logical address is divided and how the physical address is divided, I will discuss for you. Is it clear? Now your logical address is 4 KB. So meaning is that 4 into 1 KB. Am I right? So if it is byte addressable, then 4 you can represent it as 2 power 2 and 1 KB you can represent it as 2 power 10, which is nothing but, because I am saying it is a byte addressable, so it is 1K, which is nothing but 2 power 10. So 2 power 12. So you have 2 power 12 combinations are there. If you have 2 power 12 combinations are there, you need 12 bits. Okay, sorry, page size I should represent. So you need logical address of 12 bits. Okay. Similarly, if you talk about the physical address space, the physical address space is 16 KB. So 16 KB can be represented as 16 can be represented as 2 power 4 and 1K is nothing but 2 power 10, which is nothing but 2 power 14. If you have 2 power 14 combinations are there, you need minimum 14 bits. So the physical address will have 14 bits, logical address will have 12 bits. And the logical address is divided into two parts. One is the, let me write here, page number, and another one is the page offset. Similarly, the physical address is divided into two parts. One is the frame number and another one is the frame offset. Now, the page offset will depend on the size of the page and page number will be depend on the number of pages. Now if you look at page size is how much? 1 KB. If it is byte addressable, 1K is nothing but 2 power 10. So you need minimum 10 bits for the page offset. So page offset is 10 bits and the remaining bits out of 12 bits, then 10 bits are occupied for the page offset, 2 bits will be there. You can say like this, or as the process size is 4 KB and page size is 1 KB, the number of pages will be 4. If you have 4 combinations, how many bits are required? 2 bits are required. So to represent 4 pages, minimum you need 2 bits. What is that 4 pages? You will have page number 0, page number 1, page number 2, page number 3. So they can be represented as 00, 01, 10, 11. 00 for page number 0, 01 is for page number 1, 10 is for page number 2, 11 is nothing but the page number 3. So this is the way. Similarly, frame offset will be depend on the size of the frame and frame number will be depends on the number of frames. Now already we know that frame size and page size is same. As the page size is 1 KB, it requires 10 bits. Similarly, frame offset also requires 10 bits. Then the total physical address is 14 bits. If frame offset is having 10 bits, then you will have 4 bits for the frame number. Meaning is that you will have 16 frames. If you have a doubt, you can check. Your main memory size is 16 KB and your frame size is 1 KB, then number of pages will be 16. If you have 16 pages, how many bits are required to represent? 16 is nothing but 2 power 4, so you need 4 bits. So What you have to do is that if CPU generates the 12 bits address, the memory management unit use some strategy to convert this 12-bit address to a 14-bit address and get the byte or the instruction which is there in that byte and give to the CPU. So how it will be done, what is the page table, what is the purpose of page table in the paging, all these concepts I will discuss in the next video. I hope you have understood about the non-contiguous memory allocation. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.